Here we have AP calculus AP problem. Okay, let's go with the information. Use upper and lower sums to approximate the area of the region using the given number of subintervals that is of equal width. Round your answers to 3 decimal places. So here we have the function y is for square root of 5x, which represents a curve we have over here, and we have to find upper sum and lower sum. Okay, so here let's look at the region. So we have the given region from x equals to 0 to x equals to 1.0. So in the given interval, the graph, I mean the graph given by this function y is for square root of 5x is increasing. So whenever we have increasing curve in the given interval, so to get the upper sum, what we have to do is we have to do right endpoint approximation of Riemann sum. So to get the lower sum, we have to do left endpoint approximation of Riemann sum. Okay, so for that, what we have to do is we have to find the width of each subinterval, that is with the width of each rectangle over here. So for that, there is a formula, that is delta x equals to b negative a over n. So here this b is the end value of x and a is the start value of x and n is the number of rectangles. So here the ending value of x is 1.0 and the starting value of x is just 0 over here, divided by the number of rectangles is 4. So then we get delta x equals to 1.0 negative 0 is just 1 over 4. So that is equal to 0.25. So that is the width of each rectangle of the subinterval is 0.25. So then we have 0.25 over here, and here we have 0.5, and here we have 0.75, and here we have 1. Okay, now to get the upper sum, we have to do right endpoint approximation of Riemann sum. So now let me do it. So upper sum, let me write the stuff over here. So for the upper sum, the formula is going to be the general formula for Riemann sum approximation is delta x times summation of f of xi. So here delta x is the width of each rectangle, in this case is 0.25, and now we have to add the function values. So here we have to plug in values for x. Since we do upper sum and also since the given curve is increasing in the interval 0 to 1, so like the upper sum, to get upper sum, we have to right endpoint approximation of Riemann sum. So that is in each rectangle, we have to take the right endpoint. Let's consider first rectangle over here. So the left endpoint is 0, the right endpoint is 0.25. So since we do upper sum and also we do right endpoint approximation of Riemann sum, so let's take the right endpoint of the first rectangle over here, that is 0.25. That we have to plug in for x over here. So that is f of 0.25. And now we have to take the right endpoint of the second rectangle. That's over here. The right endpoint is 0.5. Then we get f of 0.5 positive. And also for the third rectangle, we have to take the right endpoint. That is 0.75. F of 0.75 positive. For the fourth rectangle, the right endpoint is f 1.0. It can be taken as 1. So now 0.25 times. We have to calculate f of 0.25. To calculate f of 0.25, we just have to use a function over here. So at the place of 5, we can use f of x. That is f of x equals to square root of 5x. So if I want to get f of 0.25, what I have to do is I have to plug in 0.25 for x over here. So when I do so, I'm getting f of, when I multiply 5 and 0.25, I'm getting 1.25. So when I take square root of for this 1.25, I'm getting 1.118 approximately. So rounded to 3 decimal places as instructed in the information. So the same thing we have to do for f of 0.5, f of 0.75 and f of 1. Okay, now so we got f of 0.25, its approximate value is 1.118 positive. So to get f of 0.5, I just have to plug in x equals to 0.5 and it has to be multiplied by 5, and then we have to take square root. So when I do all the stuff, I'm getting the value 1.581, and the value for this one is I'm getting 1.936, and the value of f of 1 is 2.236. Okay, now what I have to do is I have to add all these values and it has to be multiplied by 0.25. So when I add all these values, I'm getting 6.871. Let me write this 0.25 first, then 6.871. So when I multiply them, I'm getting 1.71775. When I round this value to the 3 decimal places, then it will become 1.718. So this is the upper sum because again I'm saying the given curve is increasing in the given interval. So to get the upper sum, we have to do right end approximation. By doing right endpoint approximation of Riemann sum, I'm getting the upper sum 1.718. Okay, now let's find lower sum. Let me erase the stuff what I've done over here. Okay, now let's find lower sum. That is, we have to do left endpoint approximation of Riemann sum. Let me write the stuff over here. So lower sum equals to, so the same formula again, delta x times summation of f of xi. So here, let me make it clear. Okay, so the value of delta x is the same. That is the width of each rectangle. That is 0.25. Already we got it. So now to get the value of the summation of f of x, we have to use the values of x. Since we do left endpoint approximation of Riemann sum, so for each rectangle we have to consider the left end point. For the first rectangle over here, the left end point is 0. So that 0 we have to plug in for x over here, that is f of 0 positive. So now for the second rectangle, the left end point is 0.25. And for the third rectangle over here, the left hand point is 0.5. And for the fourth rectangle, the left hand point is 0.75. So f of 0.75, we just add all of them because we have summation over here. So we get 0.25, and f of 0 means like in the given function, we have to replace y by f of x, and we get f of x equals to square root of 5x. So when I plug in x equals to 0 over here, so that is, let's find f of 0. So when I plug in x equals to 0 over here, 5 times 0 is 0. Square root of 0 is 0. That is the value of f of 0 is 0. Let me write it over here. Already we have evaluated the value of f of 0.25 when we did right endpoint approximation of Riemann sum. So its value is 1.118, and the value of f of 0.5 is 1.581, and the value of f of 0.75 is 1.936. Now 0.25 times, we just have to add all these values. When I add all these values, I'm getting 4.635. So when I multiply 0.25 and 4.635, I'm getting 1.15875. So, but the question says we have to round our answers to 3 decimal places. So when I round this one to 3 decimal places, I'm getting 1.159. So the lowest sum is 1.159.